Alright, this is what we call a limiting reactant problem. The reason is, unlike previous stoichiometry problems where we assumed unlimited materials of all the other things, here we're given bread and cheese, and we want to figure out which substance is going to run out, which is limiting. Now, one way to do that is to pick a product. In this case, our sandwich is our only product, and figure out how much product you can make with each substance. So 64 pieces of bread, that's sort of equivalent to moles. So as far as mapping, like it's a count, that's why it's equivalent. So I'm going to write 64 under bread, and I'm going to do it not right under bread, just to keep this idea of, avoiding that. So I'm trying to figure out how many sandwiches I can make with 64 pieces of bread. Now you can probably do this in your head. I'm just going to stick to the way we've been doing this. We're looking at a 2 and a 1. So 2 pieces of bread makes 1 sandwich, so it's getting smaller. So we're multiplying by 1/2, which will make it smaller. So 64 pieces of bread should be able to make 32 sandwiches. Not a surprise. Now what about 40 pieces of cheese? So under cheese, I'm going to write 40. And I want to bring this over and say how many sandwiches can I make with 40 pieces of cheese? So 1 piece of cheese can make 1 sandwich, so 1 over 1. So 40 pieces of cheese can make 40 sandwiches. So the reactant that is limiting is the one that holds you back. So we have enough bread to make 32, enough cheese to make 40. So bread then is our limiting reactant. That's the bread. And how many sandwiches do we actually make? You actually make the smaller number. So there's enough bread to make 32. There's enough cheese to make 40. We actually make 32. And that's how this problem goes. So here's a problem, same idea, just with chemistry. So I'm given 24 moles of sodium atoms and 20 moles of chlorine molecules, and I want to figure out which is limiting and how much NaCl will be formed. So NaCl is my product, so I'm just going to start with each chemical. I'm going to start with the 24 moles of Na and say, okay, if I have 24 moles of Na, how many moles of NaCl can I get? So I'm going from moles of Na to moles of NaCl. Every 2 makes 2, so I'm multiplying by 2 over 2. So 24 moles of Na should make 24 moles of NaCl, provided there's enough chlorine. Then we say, okay, what could 20 moles of chlorine do? So I take chlorine, I write underneath chlorine 20 moles. Bring that over. How much NaCl could we make? So here we're going from a 1 to a 2, so it's getting larger. So I'll multiply by 2 over 1, not 1 over 2. So 20 chlorines could make 40 NaCls. So I have enough sodium to make 24, enough chlorine to make 40. So then sodium is my limiting reactant because that's holding me back. If I had to go to the store and buy more of something, I'd want more sodium. How many moles of NaCl do we make? It's always the lower amount. So if we have enough of each ingredient, 1 to make 24, 1 to make 40, you will make 24. So that's the answer there. Let's do one more. So here's a scenario where I have 2 products. So one thing I want to do if I have 2 products is to find the limiting one, I want to just pick one product to analyze. So maybe I'll just look at CO2. How much CO2 can I make with 20 moles of this and 70 moles of O2? So let's start with analyzing the 20 moles of C4H10. So how much CO2 could that make? So I look at my numbers. I got a 2 and an 8, so it should get larger. I'll multiply by 8 over 2. So that times 8 over 2 would give me 80 moles of CO2, okay? And 70 moles of O2, so I put 70 moles under O2. I'm going from a 13 to an 8, so it's getting smaller. I multiply by 8/13. So 70 times 8/13 is going to give me 43.1 approximately. I'm rounding that a little bit. Okay, so that's less. So that means that oxygen is my limiting reactant, and I will make 43.1 moles of CO2. Now it also wants me to know how much water I'm going to make. So I now know that oxygen is my limiter, so I can go from 70 over to here, and I'm going to multiply here. I'm going from 13 to 10, so it's still getting smaller, but I'll be multiplying by 10 over 13. So 70 times 10 over 13 it's going to give me 53.8. Again, I'm rounding a little bit. Because I know oxygen is limiting, I can just use oxygen. I won't need to do it with this because this will definitely, I could say how much water would this make. So I'd be multiplying by 10 over 2, so I'd be getting 100, so that's too much again. So once you find out which one's limiting, all your calculations can go from that. So I will make this much CO2 and this much water, which I would expect more water than CO2 because every time I do this I get 8 CO2s and 10 water. So I should always get more H2O than CO2 in this reaction. So that is how we handle limiting reactants just with moles. Another video will do how to analyze it with grams, but basically that's it. Just doing the problem twice and then seeing which one gives you less. So until next time, I am Derek Genova. Have a delightful day.